Hmm? Negative 1 times 10 to the power of negative 3. What's Q3?
2.
2 times 10 to the power of negative 3. Q4?
1.
Negative.
Oh, it is a negative 2. Yeah, it's on the
Which one is negative 2?
the third one.
Third one, negative 2. Okay. So the charge, positive, negative, negative, positive. Now we are going to calculate the net force acted on the third charge. So we are going to calculate the negative force acted on the third charge here. Okay. So how many forces acted on this charge?
3.
3 forces. Okay, so the Coulomb force from charge 1, charge 2, and charge 4. Each charge will provide 1 Coulomb attraction or repulsion, right? And we want to add them together. Even this is one-dimensional problem, the direction is important, right? We will try to add several forces. They may be positive or negative. So here you should be careful with determining the direction of the 3 forces. First, so we plot charge 3 here. Consider the force from charge 1, let's call it F1. Should it be, what's the direction for this?
To the right. Subtracted 3.
The force acted on Q3. We talk about the force acted on Q3, provided by Q1.
Oh, so it's to the left.
To the left. Okay, any question here? How do we determine this direction?
Yes. Because you always pass the left.
First, you see this is positive, this is negative, attraction, right? And attraction acted on this object should be left. Okay. Now, how about the force acted on the charge 3 from charge 2?
To the right.
To the right, okay. Negative, negative, repulsing. Repulsing acted on Q3 is to the right. Okay? Any question here? And then, how about the force active from charge 4? It's called F4. To which direction? This is positive, right?
So it's going to be to the left. Oh, no, I'm sorry. To the right, yeah, to the right.
To the right, okay. F4. Negative, positive, so it's attraction, okay. And some attraction from the right, so of course to the right. Question? Okay, so here F1, F2, F4 means the electric force from charge 1, charge 2, charge 4 acting on charge 3. The charge 3 wouldn't give force to itself, so there is no charge F3, right? Okay. Any other question?
How did you determine what the positive How you determine what's the positive
Positive or negative, it's given.
Yeah, it's given in there.
Positive 1, negative 1. Okay, so that's the sign for the charge. Okay. Any other questions? Okay, so basically this is the part you need to pay attention to. After that, it should be straightforward. You just need to calculate the 3 forces separately and put them together according to direction indicated here, right? So basically you are going to calculate F net equals to, if we choose this is our positive, so if so, how do you write down the net force? Okay, yes, minus F, or we just say F2 plus F4 minus F1, right? Okay. And now let's try to calculate F1, F2, F3. Yeah, maybe it's better just write negative F1 plus F4 plus F4. The reason is I just realized after you calculate to 1, 2, 4, okay, we get water, so it's better to avoid any mistake to put down these numbers. Okay, now to calculate F1, F2, and F4, let's look at F1. Okay, so here you just need to be careful about every pocket you put. Should be K, Q1, Q3 divided by R13 squared. Right? You are calculating the electrostatic force between charge 1 and charge 3. Any question here? And you use the absolute value. So this will be 9 times 10 to the power of 9, okay. 1 times 10 to the power of negative 3, okay. And then what's the number you are going to put here? 2 times 10 to the power of negative 3, only positive number in the calculation. What is R13? The distance between charge 1 and charge 3. Okay, put the one. Okay. What is
4 centimeters?
4 centimeter? And what's the number you want to put here?
0.04.
0.04 squared. Okay? Each distance is 2 centimeter, 2 centimeter, and 2 centimeter. So the distance here is 4 centimeter between 1 and 3. 0.04 meter. Okay? And what's the question again?
Why is it positive 2 times 2?
During this calculation, we actually calculate the magnitude of the force. Okay. Fine. And then you get some number. Okay, I'm not going to do this calculation. And then F2 will be K Q2 Q3 divided by R23 squared. So you are going to get 9 times 10 to the power of 9 times F2 is negative 1. So you're going to put 1, positive 1, right? And positive 2 divided by here, what is the radius R?
0.02.
0.02, right? 2 centimeter from here to here. And then for F4, okay, then you can do the same thing. And you can check that you are going to put 9 times 10 to the power of 9 times 1 times power 10 to the power of negative 3, 2 times 10 to the power of negative 3, divided by again 0.02 squared. Okay. Question?
Wouldn't that be the distance between the two and not the radius? I thought the radius is half the distance.
Okay.
He's just
So
using
here,
R.
this is the confusing part of the terminology. We also call this is the radius, and it's a, in this case, it's the distance. You shouldn't think about this half of the distance.
Okay.
We call it radius. The reason why it's first confusing is right there. Think about the actual motion is good. If you have some charge here, fixed, another charge here, usually you form some circular motion. In this case, the distance is exactly the radius of the circular motion. And that's why we call the distance radius. Okay, because here you are going to have circular motion, this charge around the charge. It wouldn't make circular motion like this, so the radius wouldn't half of the distance. Okay? Any other question?